The new all-purpose ink man has arrived with all your favorite catchphrases like
It's time for game plans!
and capable of doing anything you need.
Now I'm just going to write down the steps for a Ti-83 calculator, and I'll tell you guys my Apple iOS or iPad app is called GraphingCalc83, and I'll show it to you guys in a second. But let's get some directions down. We're going to click this button called second, and then we're going to hit vars. And I put a box around it because those are kind of like the buttons you press on the calculator. And then you're going to look for something called normal CDF. Basically that stands for a normal distribution. C stands for cumulative density function. And then you're gonna, when you get old like me, you want to use something called plums. Eat lots of plums. And what that stands for is this. And the nice thing about the app I'm going to show you is it kind of tells you what it means. Okay, plum stands for, P means the probability, but you will just use norm CDF. L means the lower bound. U means upper bound or boundary. M stands for the mean or average, and S stands for the standard deviation. And again, the P, you're basically finding the probability, right? Just as a review in the normal distribution curve, do you believe in ghosts, right? And so it's always starting over here to the left up to this value. So if you wanted to find the area under this curve, this green here, you would get this value. That's what it's doing. Okay, let's get some steps for the Desmos, and then we'll try that example with an example. Okay, so the first thing you're going to click on is functions. And you're also going to look for something called normal distribution. And you're going to put in there the mean, comma, standard deviation. So again, that is the mean, and this one is the standard deviation. Okay, and then all you need to know for Desmos is the box is equal to your area. Okay, it'll be on your worksheet, but I'll just read it out loud. Let's calculate the percent of adult men taller than 70 inches. We know, given that the adult men's heights are normally distributed, and the mean is 69.3 with a standard deviation of 2.8. Okay, I'm going to show you guys first the GraphingCalc83. There it is, GraphingCalc83 is that black swirl one on the right hand side. And so the calculator commands were second, which is in the top left, it's yellow. And then I'm going to press vars, which is below the down key. And then you're going to click on number 2 where it says normal CDF. And in white there it says normal CDF, lower bound, comma, upper bound, comma, mean, comma, standard deviation. So this is our plums. The P stands for the percentage, or we call it also fancy as a p-value. And in this problem, okay, so we want to find taller than 70. So my lower bound is 70. And then we're going towards the end. So here, you can just type in like, you can just type in like 99,999. And our mean is 69.3. And our standard deviation, comma, is 2.8. And we will get this number as our answer. The answer is 0.40, you round out 13, which is like 40.13%. 40.13%. There is a way to kind of give you a visual, well, make sure we understand. We were calculating this portion. So the answer is So normally how we did it before is we found the area of the green, green plus black equals 1. And, you know, we would do the math and then we would find the black to be that answer, but the calculator can calculate it for me. Does that make sense? All right, let's try the Desmos app. So there's my Desmos app. Okay, so you're gonna click on the box. You're gonna click functions in the bottom right. And then you have a bunch of menus: trig, stats, distributions, and miscellaneous. You can go to distribution, dist, D-I-S-T, and you want to click on, there's two of them, the normal dist or distribution, so you can click on that. And isn't this cool? When your standard deviation is, you can put in there, it's already in there, but it's 0, comma, 1, close the parentheses, and you click on find cumulative probability, CDF, it will shade it. And we talked about how our answer is in the box, which is 1. The whole purple area is 1. So let's go ahead and press backspace and put in our numbers now. We basically want our mean is 120, comma, 12, close the parentheses, and then our minimum we want, sorry, I was looking at the wrong thing. Let's try that again. Functions, normal distribution. Let me start over. Functions, normal distribution, and our 69.3, comma, no spaces needed, 2.8, close the parentheses, and then we want to find the cumulative, so check it. And our minimum we wanted was 70, and our max we want is some really big number. And if you click the magnifying glass to the left there, the cool thing is it will show us what it's shading. And you notice the answer in the box is still 0.4013. Okay, so this is using technology to figure out our answers here. In this case, again, we wanted the heights of men who are over 70, and that was the black area, and we found it in two ways, using either Ti-83, Graphing Calc 83, or if you have a regular Ti-83 calculator, you can use that, or any Ti-84 Plus, all that stuff, or the Desmos app. All right, to review using either the Ti-83 or Desmos, let me go use color here. Let's say we're trying to find the black area. This is something called our lower bound or boundary, and this is the upper boundary. If you're ever going towards like infinity, just use a really large number. I use something like 99,999, and if you're using something like, if you wanted to say find the green, and this would be your lower bound, negative infinity, you don't have that in your calculator, so you just type in like negative 99,999. All right, let's try B1, and the directions are up there in direction number 3. Determine each percent using technology. The systolic blood pressure for women is normally distributed with a mean of 120. Let's write that down. And a standard deviation of 12. Okay, let's do the same thing we did before. We're going to draw a picture. Here's my picture, my curve, my mean is in the middle. And I want something that is what? less than. Less than means, we learned previously, means going towards the left. So basically we are finding out this picture right here. So again, this would be my lower bound, which I'm going to use like negative. You want to really use negative infinity, but we don't have that. And then here is actually my upper bound. Okay, let's go ahead and try that. Remember, we're going to use our acronym PLUMS for the Ti-83. So second VARS, norm CDF number 2, negative 99,999, and we're that's going to go all the way up to 120, and then our mean is 120 and our standard deviation is 12. And our answer is 0.5 or 0.50, or which is 50%. Add 0, multiply by 100. That yellow curved area is 50%. For 50% of women will have a systolic blood pressure less than 120 millimeters per Hg. I know what that is. Let me show you guys how to do that on the Desmos. Start over like you don't know. Functions, distributions, normal distribution right there. And then type in 120, 12. And I'm going to check mark cumulative probability. And my minimum already had it in there. So Desmos already has the negative infinity. My max there, we want it to be 120. And you can see the answer in the box, and you can click the magnifying glass, and that's what you need to shade. So that was question B1. B2, again, our directions from above, we have a mean of 120, standard deviation of 12. Let's determine the percent of women with a systolic blood pressure between 125 and 140. Let's do the same thing, draw our picture. And our mean here is 120. 125 is here. And 140 is here. This is green. So basically we want to find this region here in yellow. Okay. So for my calculator, instead of using a formula, my calculator commands, I just want to note that this here is my lower, and this is my upper boundary. All right, let's go ahead and put that into our calculator. Here's a cool trick. If you already have normal CDF in yours, you can just press second enter. And what it does is it's going to repeat the entry, but you're going to have to go back and change some numbers. So we wanted a number at 125 to 140, and you can just press delete, and I already have the mean and standard deviation, and our answer is 29.06. 29, or round up, 29.07. You could put the calculator commands in there if you wanted to. So my plums, my lower was 125, upper 140, mean of 120, standard deviation 12. And that should say norm CDF. Let's do that with the Desmos now. So functions, distribution, normal distribution, 120, 12. There's my curve. Close the parentheses. click on it, then I want my minimum of 125 to 140. And there's a shaded area, and then if you click on the magnifying glass, it'll tell you there's an answer in the box, 0.290, round up, 7. So we don't have to use the table now, so I can just write an answer. There's a 29.07% chance that a woman's, I don't know what systolic means, systolic blood pressure, that's a P, I guess, is between 125 and 140 millimeters per Hg. So there's our answer. Let's move on to B3. Same thing, let's go ahead and draw ourselves a picture. And our mean is 120, standard deviation is 12. And let's go ahead and figure out, we want less than 93. So is 93 less than or more than 120? It's going to be less than, so 93, that's why I'm putting it there. I'm not putting it to the right, I'm putting it to the left, it's a smaller number. And less than means to go towards the left. So basically, this is our region. To get a calculator command, this is my lower bound. So something like negative 9,999, and this is my upper. So again, the calculator command is going to be norm CDF, and this is where my plums is. My lower is negative 99,999. My upper is 93, comma, my mean is 120, and my standard deviation is 12. So there's my calculator command. Again, you can just press second enter, or we can just do it again. Second vars, number 2, CDF. And we wanted in this problem negative 99,999 to 93, comma, mean 120, comma, standard deviation 12, close parentheses, boom. And if you want to (1.22%). See if we can get the same thing over here. Okay, so the great thing is you already have all the information from the previous problem. If you don't, one mean, comma, standard deviation tells you, and then the minimum, we're just going to delete this. And we wanted that number to be 93. Same answer, right? Multiply that by 1.22%. (1.22% chance that a woman's systolic blood pressure is less than 93 millimeters per Hgs. And that's B3. Let's try B4. Alright, B4 says a doctor would like a woman's systolic blood pressure to be within 1 standard deviation of the mean. Okay, let's draw ourselves a picture. We know that the mean from direction number 3 is 120. Standard deviation is 12. Okay, within means there's an upper and a lower. 1 standard deviation. So I'm just going to put one here. Yellow is my lower. green is my upper, and determine the percent of women who meet this criteria. So remember, if you subtract one standard deviation, so subtract 12, right? That's why it's a minus 12 going to the left. You're going to get what? 108. Because if you go towards a 108 plus 12, you get 120. And if you add one standard deviation or add 12, you're going to get 132. Okay, so basically what we're trying to find is this area here. All of this. Okay, and then we already have our, here's our plums. Which is our norm CDF. Our lower is 108, upper is 132, my mean is 120, and standard deviation is 12. All right, let's put that in. Second, VARS number 2, and we said one standard deviation, which was 108. And then we added from one standard deviation 120, 132, comma 120, comma 12. And I think it's going to say 68. 68? How did I know that before I press enter? Let's try that over here. Okay, the numbers are the same. But again, we're just going to delete that one. Let's pretend you didn't know how to get there. Functions, dist, distributions, norm dist. 120, comma 12, close the parentheses, click on the box, and I want this from 108 to 132. 68.27. That's interesting. Right, they're saying that this area is 0.6827, and you just multiply that by 100. Chance that a woman's systolic blood pressure is between, or is, I'm going to erase that because you're just copying that sentence right there in green. Within one standard deviation. Okay, Mr. Ang, how did you know the answer before pressing enter and not looking at the answer key? Oh, let's make sure we're clear, so I'm going to get a different color here. One standard deviation of a normal curve is the empirical rule, 68, 95, 99.7. Oh, got it. All right, let's try B5. A woman's systolic blood pressure is considered high if it is greater than 140. Determine the percent of women who have high systolic blood pressure. Let's draw a picture. In direction number 3, the mean is 120 and the standard deviation is 12. Okay, we're looking at greater than 120 or 140. I put 140 to the right of it because it's a number that's bigger, right? These are bigger numbers. That's bigger, smaller, or less than. So greater means going towards the right. We're trying to find out this blue area. Okay, so here, because the left side of the shaded region, this is my lower. This is going to be my upper. We said use the word like positive infinity or 99,000. And other parts of our plums. Our mean is 120, standard deviation is 12, and we need norm CDF. Okay, let's put it in. Remember, the trick is press second enter. Second enter. Repeats everything, and then we're just going to have to put it in there. So 140, 9999, 99,000, 120, 12. Boom. Multiply that number by 100, you get 4.78%. 0.0478. Let's try that over here. Again, the number's already in there, so you can just change these. And I'm going to get 140. Now, if you delete this, what did it put in there? Infinity, which is 99,909. Watch, you can also put that number in there. You still get the same answer. Okay, so what did we say? 4.78% chance. That a woman will have a systolic blood pressure, then I'm just copying that, greater than 140. Like, I just got my blood tested, and it told me all these facts, just like we're writing right now. It'll tell me if I'm high, low, or within range. MMHG stands for millimeters of mercury. Yeah, millimeters of mercury. Hg is the scientific periodic table thingy. Okay. B6. Determine the percent of women with a systolic blood pressure more than 2 standard deviations below the mean. Okay, so we know from direction number 3 that the mean is 120. Standard deviation is 12. Let's draw a picture. There's my ghost, 120. Okay. 2 standard deviations below, so it means I'm going to subtract 12. This here represents 1 standard deviation, which is 108. And if you subtract 12 again, you will get 96. And it wants more than, so that's going towards the right, which means something like this. Okay, and then we gotta use our plums. Oh, way over here, huh? So my lower is gonna be 96. My upper is way over here. We said use 99,999. My mean is 120 and my standard deviation is 12. Let's put it in. I forgot all the numbers I just put in there. Second, VARS, CDF, 2 standard deviations below 108, 96, comma, 2 going above, shading above, so that's 99,999, 120, comma, 12. And our answer is going to be 97.72%. All right, let's do that with this thing. All right, all the numbers are the same, but we're doing it to 96. And you can just erase this and it goes to infinity. And there's your answer. 97, 92. 97, 92% chance. A woman's systolic blood pressure is more than 2. Oh, a little nicer, sorry. 2 standard deviations below the mean. And then they could have easily changed the problem and say less than, right? And you just go that direction.
We doing math today, ain't got time for no games. We doing math today, all work and no play. We doing math today, listen up and behave. We doing math today, we doing math today.